Okay guys, in this video we're going to put together what we know about matrix equality, the operations of addition and subtraction, as well as scalar multiplication in order to solve for some unknowns in some pretty simple matrix equations. And so looking at these here, A and B, we're going to start just by simplifying both sides of the equations using the order of operations, and then what we're going to do is solve for the unknowns. And so just like a normal equation, a real number equation, I want to call it normal, matrix equations, they have two sides, a left side and a right side, and often what we could do is we could simplify one side into a single matrix, and so that way we can have a single matrix equal to a single matrix, and in that way we could also relate corresponding entries. And so when we look at letter A here, I notice that the left side here we have some matrix subtraction going on. What I'd rather do is just add the opposite, and so what we're going to do is we're going to rewrite this expression, okay? And so we get in the top left corner here 2x plus 1, okay, 13, 15, and 4y. And instead of doing subtraction, what we're going to do is we're going to add the opposite, okay? So we're going to say plus a negative 1 times 4 times 7, or sorry, times 4, 7, negative 3, and negative 3y. So what I'm going to do is I'm going to go ahead and distribute this negative throughout the parentheses here, or parentheses, the matrix. And so everybody's going to become their opposite values. And so by adding the opposite, we're going to accomplish the same thing as subtraction. Now I'm going to go ahead and say that this matrix would be here on the right. Actually, I'll just go ahead and write it here. We say 21, 6, 18, and 49. We're saying that these still are equal. Let's go ahead and add these entries on the left. So when you add these on the left, you know, it is algebra. And so we're just going to go ahead and combine like terms. When you take 2x plus 1 plus a negative 4, you know, what would we get? You know, 2x plus 1 plus a negative 4. What ends up happening is this negative 1, or sorry, the positive 1 and the negative 4, we combine like terms and we just get 2x minus 3. So 2x plus 1 minus 4 is really 2x minus 3. 13 plus a negative 7 here, that adds up to 6. Okay. 15 plus a positive 3 is an 18. And then 4y plus 3y becomes 7y. And so now we know that all of that is still equal to this 21, 6, 18, and 49 that was on this matrix on the right. And so what we can do now is we can start to relate some of these unknown values to known values that they correspond to in the other matrix. So for instance, 2x minus 3, well, 2x minus 3, we would know that if these two matrices are equal, then 2x minus 3 and 21 have to be the same value because they are in the same entry spots. So we would say, adding 3 to both of these, we would say that really 2x equals 24, and then we could go ahead and divide both of these values by 2 to come to the conclusion that x must be equal to 12. So I'm going to keep that right there. I'm also going to go ahead and draw the conclusion that 7y is equal to 49, which is going to easily allow us also to solve for y, which is a value of 7. So looking at these two values here, one thing I do want to point out about matrix equations is that they should satisfy the equation. So when I go plug these back in, for instance, if I were to take 12 and put it in for x in this top left entry, I'd get 2 times 12 plus 1, which is really 24 plus 1, which is equal to 25. Okay, and so when I take that 25 here, minus the 4 that you see here, 25 minus 4, I should get 21. And likewise, if I were to take, say, a 7 and put it in for y, well, this was 4 times 7 right here, so that's, what, 28? And then this was negative 3 times 7 right here, so that's what, negative 21. If I took 28 and I subtracted a negative 21, which is adding a positive 21, 28 plus 21 is 49. So these do indeed work. So let's take a look at another example here where we want to simplify one side first into a single matrix and then use matrix equality to solve for unknowns. So you'll notice that in this expression here, this equation, excuse me, we see that we have scalars out in front of our matrices. And so let's go ahead and start by distributing those throughout the matrices themselves. We say 2 times 3 would be a 6. Now, when I take 2 times x minus 2, the thing is we've got to keep in mind that we're taking 2 times x minus 2. So what would you have to do if you were taking 2 times all of x minus 2? Well, you'd have to distribute. So we get 2x minus 4. Okay, let me distinguish that negative a little bit better. Likewise, here we say if I took 2 times z minus 4, I'd get 2z minus 2 times 4 is 8, and then 2 times negative 2 is negative 4. Now 2 times negative y is negative 2y, and then 2 times 10 is 20. So our second matrix here, let's go ahead and distribute the scalar of 3. We say 3 times negative 2 is negative 6. 3 times, now we have to distribute the 3 throughout 2x plus 3. So 3 times 2x is 6x. 3 times 3 is 9, so 6x plus 9. We say 3 times 6 is 18, while 3 times 0 is definitely 0. 3 times the quantity y minus 2, let's distribute here, we get 3y minus 6, and then 3 times negative 5, well, that'd be a negative 15. And this is all equal to, on the right here, 0, 29, 0, negative 4, negative 3, and 5. So let's take a look at what we have here. I suppose I would want to go ahead and add these now since I did my multiplication first. So these are both 3-row, 2-column matrices, and a 3 by 2 plus a 3 by 2 would equal this 3 by 2. So we're going to get a new 3 by 2. I'm going to give myself 3 rows and 2 columns. We're going to add component-wise. So like 6 plus negative 6 equals 0. Now we would say 2x minus 4 plus 6x plus 9. So actually what I'm going to do here is I'm going to see if I can stretch this out a little bit here. I'm going to give myself some room, because we're going to be adding some algebraic expressions on this one. I want to show you what we get here. So we say 6 plus negative 6. We say 6 plus negative 6. Now we'd say 2x minus 4, 2x minus 4 plus, now 6x plus 9, 6x plus 9. And then here we would get, oh, you guys, sorry. I needed to extend this down one more. It's got three rows. Sorry. 2z minus 8 plus 18. So we would get 2z minus 8. That plus 18. Okay. Negative 4 plus 0. Negative 4 plus 0. Negative 2y plus 3y minus 6. And then we have 20 plus negative 15, 20 plus negative 15. And of course, again, I'm going to rewrite all 3 rows here. We have 0, 29, 0, negative 4, and negative 3, 5. So a little bit of rewriting to do, right? Let's go ahead and simplify what we had in here. So we can simplify this in your head. You can go ahead and do that. But I wanted to write it out to show you what you get here. We get 0 when I add 6 plus negative 6. But when I add these together, 2x plus 6x, that would be 8x. We're just combining like terms, and then this negative 4 and this positive 9 will give me a positive 5. So 8x plus 5. 2z minus 8 plus 18. Well, negative 8 and positive 18 give us a positive 10. So this comes out to be 2z plus 10. And then we'd say negative 4 plus 0. Well, naturally, that's negative 4. Negative 2y plus positive 3y minus 6. Well, negative 2y and positive 3y just make a single y, positive y, minus 6, and then 20 minus 15, or 20 plus a negative 15 is 5. So now finally, now that we've simplified the left side down into a single matrix, what we're going to do is we're going to use the fact that equal matrices have to have equal corresponding parts to help us solve for any unknowns. So for instance, our x here, we know 8x plus 5 has to equal 29, so I'm going to go ahead and write that out. 8x plus 5 equals 29. I know that 2z plus 10 has to be equal to 0. And then lastly, I know that y minus 6 has to be equal to negative 3. So let's go ahead and solve all these algebraically as we normally would a real number equation. That's what they are. We say 8x, 29 minus 5 is 24. So our x value must be none other than 3 here. If I subtract 10 in this case, we would get 2z equals negative 10. So this leads us to the conclusion that z is negative 5. And then over here, when we add 6 to both of these, negative 3 plus 6 is a positive 3. One thing would be a good exercise to do here is go ahead and plug all of these x, y's, and z's back into the initial equation and simplify it again, but you should get 2 equal matrices here. Cheers.